Next, let's take a look at how we can wirelessly communicate with our microcontroller. This feature is one of the main reasons that I chose the ESP32 microcontroller, because we can communicate with it using Bluetooth or Wi-Fi. The example code that I have inside the communication directory is going to use Wi-Fi for the communication interface. Let's run the demo to start with. And the same thing's going to happen here. I haven't installed the dependencies for this package. When we run the demo, we see not much happened up here, and not much happened on the actual microcontroller. In fact, the display is still displaying what we have from the previous demo that we ran, the display demo. But down here in the output, we can see that the board is actually listening on a specific port. And the WS here at the very beginning means that it's using the WebSocket protocol for communicating back and forth. There are a few different ways that we could use to sort of probe and see what this microcontroller is expecting. Probably the easiest thing is to look at the code. But before we do that, I'm actually going to show you a tool called WSCat that lets us send packets of pretty much any type to the microcontroller. I have documentation on the course website in this chapter showing you how to install this tool, which is called WSCat. And we're going to say that we want to connect to essentially that same address that's listed below. I could use my JAG IP exported variable here, but I think I'll just type it out, because that's more than likely how most of you will be doing so as well. Alright, when we have our connection, you can see down here on our JAG monitor, we can see that the board said that a client connected. So this happens to be the IP address of my laptop. You can see it's pretty similar to that of the microcontroller itself, slightly different domain. And we can see the connection was initiated, a WebSocket was created, and then some extra information here that's sort of vague. It says something about enabling and disabling. I'm going to send a packet over. Let's just say hello. And on the microcontroller, it received the message, hello, spit it out to the terminal, and again, said something about enabling and then disabling. And it's a bit hard to see. I'll see if I can move the wire out of the way when I send this next packet. I'll say hello here again, and the key is to look. The key is to look at the LED that shows up right next to the USB connector here. So that's essentially what's being enabled and disabled. Whenever I send a message, any message really, it turns on the LED for about a second, and then it turns off. And if I send a bunch of messages in succession, the LED just stays on. The messages are saying that they've been received, and then a second after the last message received is the time that we disable the LED. Let's take a look at this code now. So this would be the communication demo. You can see it imports the communication library. It imports the LED library from not this directory, but from sibling directory. And then there's a pretty good amount of code here, but I'll just jump down to main and we'll start from here. Here we create something called an LED blinker object. So this is the name of the variable, this is the class type. The constructor doesn't take any arguments, that's why that's all you see on the right hand side of this assignment statement. And then the LED blinker object is sent as an argument to the WS communication, so WS for WebSocket communication. There's another argument here called the heartbeat, and MS for milliseconds. So this is essentially how long the communication object will wait for a message before it disables whatever you're having it enable or disable. So in this case, it's enabling or disabling this LED blinker object. It is worth your time to look through the WS communication object and just see if you can make some sense of the code that's in here. but that's not the code that I want to focus on for now. Instead, we'll focus on the demo here because we'll want to create our own for displaying the IP address, for example. So what is an LED blinker object? I can go to the definition of that object, and you can see that my LED blinker class implements the communication interface. I can jump to that definition, and this interface essentially means that anything that implements it has to implement the isEnabled, disable, enable methods, and then methods for onOpen, onClose, and onMessage. So if I jump back to our code here, you can see I've implemented the isEnabled, enable, and disable methods, as well as onOpen, onClose, and onMessage methods. So for our LED blinker, its members are an LED object and the current state. The constructor just sets the LED to off. So anytime we create an LED blinker, it just ensures that the LED has been set to off initially. isEnabled just returns what the current state is, or rather it returns if the current state is enabled or not. If the WS communication object calls enable on our object, our LED blinker object, it'll check if it's already enabled and it just won't do anything. If we're already enabled, calling enable shouldn't do anything extra. Otherwise, it prints out that it's enabled, sets that it's enabled, and in this case, the only really interesting thing it does is turns on the LED. And then, likewise, the disabled method does essentially the opposite. Doesn't do anything if it's already disabled, prints disabled, sets to disabled, and then turns the LED off. So these methods are what are called by the WS communication object when it has not received any sort of packet, any sort of communication for 1 second. These bits here at the top are what the WS communication object will do with any messages that it's received. So when it's able to connect to a client, it calls onOpen, and in here, onOpen just calls our enable method. So I'm sort of doubling up on the use of this enable method. onOpen only happens once. It's when we start the initial communication. onClose calls disabled, and onMessage just prints the message to the screen and then makes sure that we're still enabled. Jumping back to the output here, it should be a little bit easier to make sense of what's going on again. So I can send a message. The LED turns on over here on the right. The microcontroller says that it received the message. It enables the LED, and then after 1 second, it disables the LED. In practice, we can really send whatever we want to back and forth and do more interesting things than just print out the message itself. So later on in this semester, we'll print distance sensor data, we'll send distance sensor data back, and on message, we'll do something with that sensor data, like update a plot in a web page. But more importantly, the enable and disable functionality is essentially our main safety harness. We don't want our robot to have its motors running, lose communication with our laptops, and make it impossible for us to shut down the motors. So essentially what we'll do as part of this the exercise this week is make it so that our enable and disable will turn the motors on when we're enabled and turn them off if we are ever disabled. And it might be annoying to keep continually sending messages to make sure that the motors stay on. So instead, we'll have an automated method for that. And I should probably show one last thing here, which is if I stop communicating, that is actually a message that is also sent. So we called disabled, and the WebSocket communicator, this object being created down here, prints a nice message to this serial output saying that our WebSocket communication was closed. So one last thing to mention as part of this demo is there's another file in this directory. There's this heartbeat.html file. And this is essentially a simple interface for maintaining a connection with the microcontroller. So I'll jump back and grab the IP address. paste it into here, and let's see what happens if I set the interval too high, something like 1.5 seconds, and click connect. If you watch the LED, you can see it flicks off for a little bit and then turns back on. And that's because my interval here was 1.6 seconds, and the LED turns off after every 1 second. So let me disconnect. And I'll set this down to maybe 0.8 seconds. And it looks like I have a bug in my interface here that doesn't like it when I disconnect. So I just refresh the page, put it down here to 0.8 seconds, click connect, and now the LED, if everything's gone smoothly, should just continuously stay on. But if for some reason I close my browser, a disconnect message is sent. So that's one way to prevent the motors from continuing to run if we accidentally disconnect from our microcontroller.